Hi. In class, we handed out this, and this will be your homework, so make sure you put your name on the top of it here. And what we're doing is the difference. So we're calculating the difference, and that's actually our test statistic. And all these questions are means questions. But we're still going to walk through and ask our brain, and here's some of the steps. And again, it's less about if you got the question wrong or right, and it's more about the notes. So if you got the question right, I'd still like you to take some of the notes. I'm not looking for every single piece of it, but the majority of the notes, because again, we're looking for building a way of working through these problems. Okay. So it says researchers have found some disease in some plants, and so they've thought about putting some herbicide on there and see if that would benefit them. So notice we can see from the problem that we're measuring something. So this is definitely mean, and we've got two things going on. So really the only thing in our brain where we might be worried about is whether this is a paired test. But it doesn't look like it. When I read through here, I don't see them putting herbicide A on one plant at one time and then B at another time at the same plant, nothing like that, no matched pair situation. So this is just your basic run-of-the-mill two-sample test. I also don't see a sigma. So without a sigma, I don't know the standard deviation of the population of either herbicide groups. And so this is definitely going to be a t-test. So as I read through here, I did notice they didn't add in. So in 1, if I call this my group 1, would be 10. And in 2 would be 10. And right off the bat, I'm noticing these are not very big. So it's definitely a mean question. If it says, we wish to determine, is there a significant difference? So if they're asking a yes or no question in relation to, is there a difference or not, then that's got to be a significance test. They're not asking you to estimate anything. An estimate would have been a confidence interval. Okay. So now let's do this two-sample test. Okay. So anytime you do a two-sample test, this is kind of what you're doing in your calculator. We're going to do a two-sample t-test because there was no standard deviation of the population. And our data input, we were given our statistics, and you're going to put all that information in from the table. Your alternate hypothesis. I read through this question a couple times, and there was no leaning one way or another. There was nothing as far as an indication that we thought herbicide A worked any better than B. So we're just trying to see if there is a difference between the two, meaning we're totally thinking that A might be better or B might be better, or they might be exactly the same. So our H sub O, we have to assume that they're exactly the same. Okay? And our alternate hypothesis is that, well, we have a hunch that they're not the same, because we always think, well, if one's better, I'd rather use the one that is better. The minute you set this as your hypothesis, you're now doing a two-sided test. Okay, so make sure you don't hit enter with it saying pooled yes. We definitely want to say pooled no. And when I type that in my calculator, I get a t of negative 3.43. And we want to talk about, and we talked about in class, well, what is the t? And then how does the calculator use the t to find the p? Okay. So I get my t-value of negative 3.43, but because this is a two-sided test, ultimately your calculator is saying, wow, if there is in fact no difference, so that's H sub O, if there is in fact no difference between these two, then the outcome of your sample has a t-value, which is an approximation of a z-score, of negative 3.43, at least as extreme. So since it's a two-sided, you actually also, your calculator is calculating the p-value, the area to the left of negative 3.43, and it's also calculating the area to the right of 3.03, which is why it's called a two-sided test. And the p-value it comes up with is very rare. And we know it's rare. That's a very rare and extreme z-value. So it would also be an extreme t-value. So you might be thinking, well, I didn't get that as my choice. So if I go back to my multiple choice questions, I got a positive. So what does that mean? Well, technically, if you go back through the problem and you call herbicide A 2 and herbicide B 1, you'll actually get this positive one. So whether you get a negative or a positive in a two-sided test, your calculator is calculating the area to the curve to the positive and to the negative, because you're not concerned whether one is bigger or one is less than. You're concerned as least as extreme. So I'm hoping that's starting to make sense there. Okay, question 6, down the hatch. Question 7. Okay, so we're reading through question 7. It says, we wish to test if more calcium still tastes okay. They randomly divided them into groups. Well, that goes along with our lecture. So we learned a little bit more about our conditions today in class, and we want to collect this information and see if we would be able to do a T procedure or if it would not be safe. So they're asking us, would these be reasons to not perform a t-value? Well, the correct answer is no. None of these would be a good enough reason to not do a T procedure. Okay, we definitely talked about this in class today. So let's look at, well, what would I write out on my paper if I was performing this question, especially if this question was not a multiple choice but a free response. So you always want to collect your information, especially if they don't collect it. And I called mu1 when they put extra calcium. Oh, that's my group 1. They called it group 1. And there was your mean and your standard deviation, and there's your n. Now, once again, I've got no sigma. I don't know the standard deviation of the population, which means we will do a t-test or a T procedure if the conditions are met. Now, group 2 does not have calcium, and here's its data. So the types of conditions that we reviewed in class were, we need random assignment. We definitely asked all 61 people to taste yogurt. So we want the randomness to be in relation to each person. Each of these 62 people had an equal chance of either getting extra calcium or not getting extra calcium. And it appears that that's been met. Also, in relation to the central limit theorem, we need at least 30 in each group, which we have. That's a big deal. And then last, we need to design the experiment so that it is in fact independent. So if all those are met, we can make an inference about people like the volunteers in our taste test. So now going back over here, it says the sample median and mean of the true groups were slightly different. That happens all the time. The word slightly means not very much. So what would that look like? Well, something that's slightly skewed to the right would have a median here and a mean slightly to the right, because that's what right skew means, is that the mean is pulled a little to the right. So all that means is it's slightly different. These are really close to each other, or vice versa. I'm skewed a little bit to the left, which just means my median is here and my mean is pulled a little to the left. They're saying, you see that data? We get data like that all the time. And we actually would proceed, even if n was less than 30, we would still proceed with the data as long as we didn't have any extreme skewness or any outliers or anything unusual about the data. So this is not going to stop us, even if n was less than 30. The distribution of the data of the two groups were slightly skewed right. Once again, this word slightly, we proceed with that all the time. As long as it's only slightly skewed right or left, we would even proceed with this if n was less than 30, but it's not, so that's not going to stop us. Next, the datas are integers, so it can't be normal. Okay, that seems really preposterous. What are they saying there? Well, people could say anywhere from 1 to 10, And if that is the case, I have no idea why that would stop me from having a normal graph, right? You can have a normal graph that goes from 1 to 10. So I think they're trying to confuse you with the area under a curve has to be 1. And I think maybe they're trying to confuse you with that concept. Last, the standard deviations of both samples were different, okay? That happens every time. Look, these were different, and we had a low in value, and we still proceeded. So the big kicker here is because this is 30, we're good to go because of the central limit theorem. But each of these little conditions would also not stop us, even if n was small. So we're going to pick E. Check out the next video for question 8, 9, and 10. They're all about the same subject.